Dear Professor, we are from Vietnam, and so today I would like to introduce our project. Its name is BreatheSafe, an IoT-based air pollution monitoring and system. So the system is designed to monitor air quality in real time, detect a harmful gases, and send to an instant alert via email when safety thresholds are exceeded. To build the system, we are required the following hardware components. So first one, I will introduce about the Raspberry Pi 5. This one is the main board that acts as the main processing unit. It collects a raw data from the sensor, so processes the signals and transit the result into the ThinkSpeak cloud platform for real-time monitoring. So the second one, I will use the groove-based hard hat. This one we call a groove-based hat. So this is an expansion board that connects to directly the Raspberry Pi to allowing safe and convenient use of Groove modules. It protects a GPIO pin from the overcurrent and simplifies the connection to off devices such as the buzzer here. So the next one is ADS1115, as well as an ADC analog to digital converter. This mini one. The mini one is converts analog signals from MQ2 and MQ7 sensor into the digital values. So this is the essential because the Raspberry cannot directly read the analog input. The first sensor I will be introducing the HT11 sensor module here. This measures the temperature and humidity. Since the module already includes an pull-up resistor, it is complete plug and play. Next one, the bigger one, we have an MQ2 sensor. MQ2 sensor detects a flammable gases such as LPG, methane, hydrogen, as well as smoke. On the onboard circuit and load resistor make it easy to connect, and only an analog output is needed to the ADC. So the smaller one and black one is MQ7 sensor. This one is basically designed to measure carbon dioxide monoxide as well as CO like the MQ2. It comes with an integrated load resistor for a simple connection through the ADC. And the biggest one in this board is LCD display 16x2. We also call I2C display the temperature, humidity, and gas reading in real time for local monitoring. So here you can see the status in the MQ2 or the MQ7, and the status air for now is very good, with the message that the air quality is good today. Enjoy your day outdoor. So the next one I will introduce is the Groove buzzer here. We also know as the alarm operates as a 3.325 volts and generate the audible alert whenever a gas level exceeds the safe threshold. It is connected via Groove-based hearts for the GPIO protection. And last but not least, we come to the 5-volt power supply, provide a stable power to Raspberry Pi and all the connected module here. So we also connected all of this device throughout a jumbo wires used to connecting non-groove module and enable flexibility prototyping. And we also connect Wi-Fi to ensure data transmission to the ThinkSpeak platform, allowing remote monitoring on both PC and mobile device.
What?
Comes to the cloud system, we have is ThinkSpeak monitoring. Once processed by the Raspberry Pi, all the sensor data is transmitted to the ThinkSpeak platform. So here, the data can be visualized in the real time across 4 fields here. First one is we have a temperature field. Number 2 is humidity. Third field is a gas level detected by the MQ2 sensor. And the last one is carbon monoxide concentrated detected by the MQ7 here. So this one enables the user to remotely monitor air quality from anywhere using either a computer or a mobile device with a clear and visual chart. And comes to our website management, we first split to the registration and account verification. Our system supports a secure account registration flow. First, the user have to enter their username, email, password, and then click register. Importantly, the password is never stored in the plain text. It hashed before being saved into MongoDB, and which protects user information and strengthens overall data security. So here we have to send the user the email to activate the account after register. So after activating, we comes to the login UI. So now the user have to log in information that they just registered now and log into the home page. In the MongoDB, we have hashed the password, which protects the user information and strengthens overall data security. And after successful verification, the system automatically logs into directly the dashboard. And this is our home page that user will manage their sensors. So the dashboard is the central interface of the system, designed with the HTML and Bootstrap 5. A key highlight is our integration of WebSocket, which enable real-time sensor with updates without a page reload. And the dashboard includes 4 real-time charts, as you can see here: temperature, humidity from DHT11, gas from MQ2, and CO from MQ7. We also use an alert banner here that appears immediately when any metric exceeds in the threshold. Now we come to reality testing. First one, we will test the DHT11 with the temperature testing. So now we use the candle to volume up the heat. As you can see in our system, in the chart of temperature using by DHT11, is rising into 30.3 reset. The alarm will alert in a 31 Celsius degree. Oh, sorry. I'm in a 32 Celsius degree, and the buzzer will be alarmed like now. And in the LCD, it will alert that high temperature, entering please, to alert the user that the temperature is pretty high, so they need to drink plenty of water. Okay, next one, we also use the DHT11 to test the humidity. Now you can see on the screen here with the chart, it display a 37% of humidity, and here we set 41 percentage of we set 46 percentage and the humidity. So now it's rise to 39, and we will wait for until the humidity is rising to the 46%, and the alarm will be alert the user. And next one, we will test a DHT11 with the humidity. We set for 43%. And now the alarm will alert that the high humidity here in the LCD, and they alert the user to reduce activities related to water. So when the humidity is under 43%, the alarm will be turned off. Next one, we will test into the MQ2 with the air quality. Now I have a gas here, a lighter, and I will use the gas in the lighter to test the MQ2. So you can see when we just turn up the gas, and it will alert the poor air considering, and the LCD will alert that air quality is poor. So consider to wear a mask when the user go outdoor. And the final one, we will test the MQ7, also with the air quality. And we also use the lighter to pump off the gas out to test. So as you can see here, when we pump the gas into the MQ7, the alert will be turned on. And so yeah, this is our application that help user to test about the temperature, humidity, and air quality via MQ2 and MQ7. And the user also receive a Gmail when the sensor alert. So as the example here, we can see the alert send email with the temperature, with the level is high, with the value is 32.6 within 5 minutes. And we have an editable threshold. User can click edit to adjust limit in auto or manual modes. All changes are saved directly to MongoDB. A recent alert section showing the latest warning in real time. In the left side, where the so now we can set a min and max. A recent alert section showing the latest warning in real time. In the header, left side is the weather widget powered by recently we just test a temperature by DHT11 and now we can edit to another number. And now for the puzzle will stop. And in the left side, we have the weather widget with the power by Open Material API, showing location, time, coordinate, temperature, humidity, and wind speed. And in the right side, a history button that lets users see the past alert. This is our chatbot, where the chatbot, you just input your location and you will receive a response about the place you are in with the temperature, the wind speed, and update in real time. We use it by data source from Open Material API. And in the history, in the left side with the yellow button, we have a history button that lets the user review past alerts with the filter for a month, year, device, for a month, years, device, and also a parameter you want to check and the level, poor, warm, high, acute. And we also limit, you can even a per day alert limit like 50, 100 to log the number of alert you have received of before. So conclusion, in summary, the BreatheSafe provides a complete solution for the monitor and improving air quality, a reliable hardware setup with Raspberry Pi, sensors, and alarms. ThinkSpeak integration for real-time visualization, user authentication with the email verification, and a feature-rich dashboard with the live alert, editable threshold, and a full history tracking. A built-in weather chatbot to provide a worldwide weather data. Thank you for listening.